This is section 6.6. This is part 3, function operations. In this part of section 6.6, we're going to find the composition of functions. Now, composition essentially is going to be talking about taking one function and putting it in the other. Okay, we're going to compose them. We're going to put one into the other. Now, you'll notice again this information up here up top is the same information that you've had on your other note sheets. The only thing that's different here is on the bottom. So we're going to talk about how to find the composition of functions. So to compose functions, it's really just a fancy way of substitution. Okay? You're going to take one of the expressions or one of the functions and put it into the other function for the variable. Okay? You're going to have some that are, you're going to have to end up multiplying, distributing, combining some like terms, foiling. There's going to be a bunch of different types of things we're all going to kind of put together here. Okay? Again, the domain is the same process. Domain, if you have a square root or you have a fraction, that's the only two times where you're going to have a domain that's not all real numbers. Okay, now let's dive into these examples. Okay? A couple things I want you to see in terms of notation. Okay? A lot of times you'll see that it'll either look like this is composition, okay, it's not multiplication, or they'll go and they'll make it look like this. It'll look like fog, or it'll look like goff, in this case, GOF, but it's not really an O. Okay, it's not really an O in there. What that means is that is F composition G, or G composition F. It's a composition symbol. It's not an O. Okay? So I just wanted to clarify that notation with you. All right, so number one, it says let f of x be x squared minus 9, g of x be x plus 3. What are f of x composition g of x? So we're going to take, in this case, we're going to take g and put it into f for the variable. Again, all this is a fancy way of substitution. Okay? So, let's find f of x composition g of x. So again, this tells me we're going to take g, which in this case g is x plus 3, and we're going to put it into the equation right there for the x. So in this case, f of x is x squared plus 9. We're going to replace x with x plus 3. So instead of an x here, we're going to have an x plus 3 squared plus 9. Okay? So now all I did is I replaced x with x plus 3. Again, it's just a simple fancy way of substitution. Okay? So now I've got to simplify this. So I'm going to have to FOIL this out. And this is x squared plus 6x plus 9. And, oh, that's not a plus 9, so we're going to do some erasing here. This here is a minus 9 at the end. And then I got to put a minus 9 at the end of that as well. Okay, so all I did was I took x plus 3 squared, wrote it as x plus 3, x plus 3, and did the FOIL method to get that. Okay, now I've got to combine my like terms. So I've got positive 9 and negative 9. Those guys are going to go away, so I'm just left with x squared plus 6x. My domain. I don't have any square roots, and I don't have a fraction, so my domain is going to be all reals. Okay, all right, now I'm going to take g of x and compose it with f of x. So that, again, that means I'm going to take f and put it in for g. So now this time, I'm going to go the other way. So I'm going to take this f of x, this function, and put it in for that. So g of x is x plus 3. I'm going to replace the x with an x squared minus 9, and then a plus 3. Now I combine my like terms, and I end up with an x squared minus a 6. Now, I can't do any factoring here because it's not a perfect square, so I'm done. So the one thing I got to do here left over is my domain. There's no square roots. There's no fractions, so my domain is all reals. Okay, let's take a look here at the second example. F of x this time is 4x plus 7. G of x is the square root of x plus x. Okay, so first one, I'm going to take f and I'm going to compose it with g. Okay, so I'm going to take g and put it into f. So f of x is 4x plus 7. I'm going to replace the 4x plus 7 the x with the square root of x plus x. So I'm going to take 4. Instead of x, it's going to be the square root of x plus 7. Now I need to distribute. So if I distribute the 4, I've got 4 times the square root of x plus 4x and then plus 7. None of these three are like terms. Okay, so I can't simplify anymore. Now I need to figure out my domain. Again, is there a square root or a fraction? There's no fraction, but there is a square root. So again, I have to take what's inside the square root, set it greater than or equal to 0. And in this case, I have nothing to solve, so my domain is x has to be greater than or equal to 0. The other way, if I go g composition f of x, that tells me I'm putting f into g. So g is the square root of x plus x. So everywhere there's an x, I'm going to substitute this in. Take this, put it in here, and in here. It's going to go in both. So the square root of 4x plus 7 plus 4x plus 7. Now, these again are not like terms, so I can't go any further right now. That's all the further I'm going to be able to go. Okay, so my domain. Again, I have something in the square root. So take what's in the square root, and it's got to be greater than or equal to 0. So if I subtract 7, 4x is greater than or equal to negative 7. And divide by 4, x is greater than or equal to negative 7/4. That'll be my domain. It has to be bigger than that number. Otherwise, I have a negative underneath the square root. Okay, now let's take a look at this last example. And this last example is kind of interesting because we've got a trinomial and a binomial. So, I want to find f of x, composition g of x. And you'll notice here, I'm going to flip this around. I want to flip these guys around. Let's cross this guy out and let's make this g of x, composition f of x. Okay, we'll go both ways. Okay, so in the first one, I'm going to take g and I'm going to put it in for every x here. So I've got 3 times the quantity, 3x plus 1 squared, minus 11 times, instead of an x, I've got a 3x plus 1, and then minus 4. Okay, 3x plus 1 squared can be written as 3x plus 1 times 3x plus 1, and I would use the FOIL method, which would give me 3 times the quantity, 9x squared, plus 6x plus 1. I'm going to distribute the negative 11, minus 33x, minus 11, and then bring down the minus 4. Now I'm going to distribute the 3. So 27x squared, plus 18x, plus 3, minus 33x, minus 11, minus 4. And now all I need to do is combine my like terms. I have no other squared terms, so 27x squared. Positive 18 and negative 33x is negative 15x. 3 minus 11 is negative 8, and negative 4 more is negative 12. Okay, now there's not any further I can go here. I've simplified all my like terms, combined all those. So now all I need to do is figure out my domain. In my domain, there's no square root, there's no fraction, So my domain in this case is going to be all real numbers. Okay, now let's go the other way. Let's take f and let's put it into g. So again, I'm going to have 3x plus 1. And I'm going to take this right here and put it in for the x. So it's going to be 3 times the quantity, 3x squared minus 11x minus 4, and then a plus 1. Got to distribute the 3, so I get 9x squared minus 33x minus 12 plus 1. Combine my like terms at the end, so I have 9x squared minus 33x and minus 11. Again, I've got no more like terms. There's nothing else to simplify, so I'm finished in this case, and I got to do my domain. There's no square root, there's no fractions, so my domain is all reals. Okay, so this covers part 3 of section 6.6, which is the composition of functions. Remember, the composition of functions is really just a fancy way of doing substitution. Okay, don't forget to take care of your WSQ here once you get done watching this, and this finishes up 6.6 part 3.